Rivers. These dynamic arteries of our planet course through continents, carving landscapes and sustaining ecosystems. They are the lifeblood of our world, providing sustenance and shaping civilizations. From the earliest human settlements to modern cities, rivers have been central to human development. They have nurtured ancient cultures, supported agriculture, and facilitated trade and communication. The history of human civilization is deeply intertwined with the history of rivers. From the snow-capped peaks of mountains to the vast expanse of oceans, rivers connect and nourish, their journey a testament to the power and beauty of nature's design. They traverse diverse terrains, each stretch of water telling a different story. Their currents carry not just water but also stories. Tales of ancient cultures, vibrant ecosystems, and the delicate balance of our planet's climate. Rivers are the veins through which the lifeblood of our planet flows, sustaining both human and natural communities. Rivers are more than just geographical features, they are intricate ecosystems teeming with life. Fish navigate their currents, finding food and shelter in their depths. Birds build their nests along their banks, relying on the river's resources to raise their young. And countless microscopic organisms thrive within their depths, forming the foundation of the aquatic food web. These tiny creatures play a crucial role in maintaining the health and balance of river ecosystems. The health of a river is a barometer of the health of the surrounding environment, reflecting the delicate balance of nature. Pollution and human activities can disrupt this balance, leading to dire consequences for both wildlife and people. As we delve into the world of rivers, we uncover not just their physical characteristics, but also their ecological significance and the profound influence they exert on our planet's climate. Scientists study rivers to understand their role in the global ecosystem and to find ways to protect and preserve these vital waterways. From the mighty Amazon, a sprawling giant that breathes life into the rainforest, to the Nile, which has sustained civilizations for millennia, to the icy rivers of the Arctic, carving paths through frozen landscapes, each river holds a unique story. These stories are written in the landscapes they shape and the lives they touch. Each river, with its unique path and character, contributes to the rich tapestry of our planet's natural heritage. They are not just bodies of water, but dynamic systems that support a myriad of life forms. Their journeys, shaped by geology, climate, and time, have sculpted some of the most awe-inspiring landscapes on Earth. The Grand Canyon, for instance, stands as a testament to the erosive power of the Colorado River over millions of years. And it is within these watery veins that we find a microcosm of our planet's interconnectedness, a delicate balance of life, water, and climate. Rivers remind us of the intricate and fragile web of life that sustains our world, urging us to protect and cherish these vital natural resources. The Nile River, a name synonymous with ancient civilizations and fertile lands, holds a place of reverence in human history. It has been the cradle of one of the world's most fascinating and enduring cultures, the ancient Egyptians, who built their lives around its life-giving waters. Flowing for over 6,650 kilometers, it has long been considered the world's longest river, a title not without its contenders. This immense length allows the Nile to traverse diverse terrains, from the lush highlands of East Africa to the arid deserts of Sudan and Egypt. The debate surrounding the Nile's true length hinges on the definition of a river's source and the inclusion of its many tributaries. The complexity of measuring a river's length is compounded by the numerous streams and smaller rivers that feed into the main river, each contributing to its overall flow. Some argue that the Amazon River, with its vast network of tributaries, surpasses the Nile in length. The Amazon's extensive basin and the sheer volume of water it carries make it a formidable rival in the contest for the title of the world's longest river. Central to this debate is the intricate web of tributaries that feed the Nile. These tributaries, each with their own unique characteristics and origins, play a crucial role in defining the Nile's path and its overall length. Each tributary, a river in its own right, contributes to the Nile's might, adding to its volume and shaping its character. The confluence of these waters creates a powerful and dynamic river system that has supported human life for thousands of years. The White Nile, originating in the Great Lakes region of Central Africa, and the Blue Nile, surging from the Ethiopian highlands, converge in Khartoum, Sudan, to form the mighty river we know as the Nile. This confluence is a significant geographical and cultural landmark, symbolizing the union of two great watercourses. These tributaries, along with countless smaller streams and rivers, paint a complex picture of interconnectedness, highlighting the Nile's dependence on a vast catchment area. This network of waterways ensures a continuous supply of water, even in times of drought, making the Nile a reliable source of sustenance. Beyond its length, the Nile's significance lies in its role as a lifeline for millions of people. It provides water for drinking, agriculture and industry, supporting the livelihoods of communities along its banks. For millennia, its annual floods have deposited fertile silt along its banks, creating a ribbon of life in an otherwise arid region. This natural irrigation system has allowed civilizations to thrive, turning desert lands into fertile fields. Ancient civilizations, including the Egyptians, flourished along its banks, their cultures intricately intertwined with the river's rhythms. The Nile was central to their agricultural practices, religious beliefs and daily life, influencing everything from their calendar to their mythology. The Nile was not just a source of water, but also a means of transportation, communication, and a source of inspiration for their art, religion, and way of life. Boats sailed its waters, carrying goods and people, while its majestic presence inspired countless works of art and literature, leaving an indelible mark on human history. High above the Earth's surface, invisible to the naked eye, flow rivers of a different kind, atmospheric rivers. These narrow corridors of concentrated moisture in the atmosphere play a crucial role in transporting vast amounts of water vapor across the globe. Originating over tropical oceans where evaporation rates are high, atmospheric rivers act as giant conveyor belts, carrying moisture-laden air towards the poles. These rivers in the sky are essential components of the global water cycle, influencing weather patterns and impacting regional climates. When an atmospheric river makes landfall, it can unleash its stored moisture in the form of intense rainfall or snowfall. While these events can replenish water supplies and nourish ecosystems, they can also lead to devastating floods and landslides, particularly in mountainous regions. The orographic effect, where moist air is forced upwards by mountains, can exacerbate rainfall from atmospheric rivers, leading to extreme precipitation events. Understanding atmospheric rivers is crucial for predicting and mitigating the impacts of extreme weather events. Scientists are constantly monitoring these rivers in the sky, using satellites and weather models to track their movement and intensity. By improving our understanding of these atmospheric phenomena, we can better prepare for floods, droughts, and other weather-related hazards, protecting lives and livelihoods. While atmospheric rivers transport moisture above our heads, another type of river, invisible yet equally important, operates on a global scale: airborne rivers. These rivers are not bound by the physical constraints of the Earth's surface. These vast, flowing currents of water vapor, carried by winds high in the atmosphere, play a crucial role in the global water cycle, connecting distant parts of the planet and influencing weather patterns thousands of miles away. They are essential in maintaining the balance of our climate system. Unlike their terrestrial counterparts, airborne rivers are not confined to riverbeds. They flow freely through the atmosphere, their paths dictated by wind patterns and atmospheric pressure systems. This freedom allows them to traverse vast distances, linking ecosystems and climates across the globe. Airborne rivers act as invisible conduits, transferring moisture from regions of high evaporation, such as tropical oceans, to regions where precipitation exceeds evaporation, such as higher latitudes and continental interiors. This transfer is vital for sustaining life in various parts of the world. The continuous movement of water vapor through these airborne rivers helps to regulate Earth's climate, distributing heat and moisture around the globe. This process ensures that no single region becomes too dry or too wet, maintaining a delicate balance. The Amazon rainforest, often referred to as the lungs of the planet, relies heavily on airborne rivers to maintain its humidity and support its rich biodiversity. These rivers bring in moisture that is crucial for the survival of countless species. Disruptions to these atmospheric waterways, such as those caused by climate change, can have far-reaching consequences. Alterations in wind patterns, rising global temperatures, and changes in precipitation patterns can all impact the flow and intensity of airborne rivers. These changes can potentially lead to more extreme weather events, such as droughts in some regions and floods in others. The delicate balance maintained by airborne rivers is crucial for the stability of our climate. Understanding the role of airborne rivers in the global water cycle is essential for predicting and mitigating the impacts of climate change. By studying these invisible rivers, scientists can develop better models to forecast weather patterns and prepare for extreme events. The continuous study and monitoring of airborne rivers are vital for our efforts to combat climate change. As we learn more about these unseen architects of our climate, we can develop strategies to protect and preserve the delicate balance they maintain. The Amazon rainforest, often referred to as the lungs of the planet, relies heavily on airborne rivers to maintain its humidity and support its rich biodiversity. These rivers bring in moisture that is crucial for the survival of countless species. Disruptions to these atmospheric waterways, such as those caused by climate change, can have far-reaching consequences. Alterations in wind patterns, rising global temperatures, and changes in precipitation patterns can all impact the flow and intensity of airborne rivers. These changes can potentially lead to more extreme weather events, such as droughts in some regions and floods in others. The delicate balance maintained by airborne rivers is crucial for the stability of our climate. Understanding the role of airborne rivers in the global water cycle is essential for predicting and mitigating the impacts of climate change. By studying these invisible rivers, scientists can develop better models to forecast weather patterns and prepare for extreme events.